Hi, today we're going to talk about how to perform mean atomic number or MAN background corrections on your WS data. Let's start by reviewing the MAN method. So as opposed to normal off-peak measurements where you detune the spectrometer on either side to measure the background intensity and interpolate to obtain the intensity under the peak, with the MAN method we essentially measure the peak intensity in materials that do not contain the element of interest. So for example, in this plot, we have iron K alpha here, measured on spectrometer 5 LIF. And on the x-axis here, we have the so-called mean atomic number, or Z bar. And this was traditionally calculated using mass fractions, and now we know to use a Z fraction method, which produces more accurate results. So basically, in all these four materials, we are measuring iron K alpha, but there's no iron in any of these materials, so we're essentially getting a measurement of the background intensity for that atomic number, since background intensity is essentially a function of Z bar, as Kramer's law originally proposed it. So if you want to go into more details about the mean atomic number background and how it's done, the original paper was published in 1996. Here, you can read that. And then we published another paper in 2023 that was a little bit more detail and also provides the theoretical and experimental basis for performing the Z fraction calculation for average atomic number as opposed to mass fraction. And in fact, what we find is that we can get a very good fit using the Z bar method. All right, so let's start by showing how to acquire data for mean atomic number background corrections. We'll start Pro from A. We'll connect to the microprobe, in this case a virtual Joule instrument. And we'll make a new run. There we go. And we'll just give this a name, doesn't really matter. Call it MAN test 2. And what we're going to do here now is we're going to create a sample, and we're going to add some elements to it. So just to simplify things, we're just going to do a few elements in this little test run here. We'll do silicon on spectrometer 1, and we will change the background to a mean atomic number as opposed to off-peak, which is the default. And then let's add in another element. Let's do iron. Again, we'll choose a spectrometer and change it to MAN again. All right, so now we have our unknown sample with silicon and iron K alpha. And as you can see, the background method is MAN. And if we now go to, let's say we wanted to add some standards to our run, and again, we want to add standards that both for our primary elements and for our backgrounds. So let's go here. Let's think about silicon and iron. So obviously, we could use silicon as a primary standard for silicon, and for iron, we could use iron oxide. But then we also want some standards, and we could use iron as a mean atomic number background for silicon because it has no silicon, and we can use silicon as the mean atomic number background for iron because it has no iron. But we also want to have a few more points there, so to get a trend with atomic numbers. So let's add a synthetic MgO, and maybe aluminum oxide, and then maybe titanium oxide, and then maybe some nickel oxide, just as the high Z outlier there. All right, so now we have these, and we go ahead and assign these standards. Okay, and we've got quartz as the primary standard for iron, and primary standard for silicon, and iron oxide as the primary standard for iron. All right, now if we wanted to acquire, we would now, of course, as usual, peek up our elements and check our PHAs, and we only would need to do wave scans on elements that were done using mean atomic number, using off-peak backgrounds. So you can change that as I did here in the elements cations window here, but we can also look at the background types for each element, because in Pro for EPMA you can do a different background correction for your standards and a different background correction for unknowns. So right now we've got the mean atomic number assigned for the unknown for silicon iron, but using off-peak for standards. And so we could change that by clicking here and then saying we want to do mean atomic number on standards also. The other way you can do it, of course, is you can just go into you could make a new sample and call it, say, make a standard and just say MGO, for example. And then you'll notice that it did change the silicon to MAN, but the iron is still linear off-peak. So we can go back in here on the iron sample here and change that for the standard to MAN. And if we go back to our acquisition options, you can see that we have MAN for both the standard and the unknown for silicon and iron. And of course, you can change everything to MAN over here or change all to off-peak over here. So we then go to our automate window and we select the standards we're going to run, and we could say, peak our standards and acquire our standards, and then assign the MAN backgrounds. I'm going to pause the video here so we can go ahead and acquire that and save time. See you in a minute. All right, so we peaked our spectrometers and we have acquired our standards, both primary and MAN. So now let's look at the data. If you look at the analyze window, you can see we ran our standards here. And we are, of course, looking at the raw data. You can see since there's no silicon or iron in magnesium, we are essentially seeing the on-peak intensities only here. Now, to assign the mean atomic number background standards to the fit, we go to this analytical and assign mean atomic number background fits. So the program loads a default set of assignments just to start off with. And that may be good enough or may not be. Here you can see we have a pretty good fit here for our 12, which is our MgO, 13, which is our Al2O3, this is TiO2, the iron oxide, and nickel oxide. And if we go to iron here, you can see we have another pretty good fit for the iron. Now, what you want to be aware of is that if you have an interference or a trace contamination, that will show up in these plots as an elevated intensity. And you can deselect those outliers using a control click on the thing here. So if I wanted to remove, say there was a problem here with this aluminum standard, I could unselect it and then update the fit here, and that would update it there. Now, as it turns out, aluminum oxide is not a problem, so we'll leave it. We'll reassign the fit there. All right, so that's how you do it. And then once you've done that, you can now analyze your standards as though they were unknowns. And we have a background correction fit, and you can see here the silicon is within a standard deviation of 0. In the case of iron, we actually have a slight outlier because there is actually 80 ppm supposedly in this iron, in the MgO of iron, and you can see we're actually detecting a little bit of it there. So we could, if we wanted to be absolutely rigorous about it, we would go back into the analytical assignments fit and remove iron from our MgO fit, which means we go back here, and we would go back to our iron fit, and then we would remove the, actually, okay, so this is how the software is smarter than I am, because it had already deselected the iron oxide from this fit because it realized there was iron in it from the standard database. So that's all taken care of. Anyway, that's how you do it. All right, I hope you found that interesting, and please post any comments or questions to the YouTube channel comments, and I will try to answer them, or go to our user forum at smf.probesoftware.com and join the discussion there. All right, thank you very much.